Same model, same weights. Watch. On the left, I ask it to write a line about the ocean and it says, the ocean is large and contains water. Flat, safe, a little dead. Now the right side. Exact same model, exact same brain, one number changed, and it says, the ocean hums old hymns to drowned cathedrals. Two completely different writers, one machine. The only thing different between them is a single dial, and by the end of this episode, that dial is yours, and you will know exactly what it does and when to turn it. Here is the promise. In this one episode, you will learn the one setting behind every chatbot's personality, the single most common way to break text generation, and the simple loop that turns a pile of numbers into a flowing sentence. 3 things: the dial, the trap, and the loop. And the dial is a knob you can go change yourself tonight in any chatbot with a temperature setting. Let's earn it. Last episode, we trained the machine. The loss curve fell, the babble sharpened into English, and we ended right here on this glowing bar chart. Remember it. The model reads a sentence, the cat sat on the, and it does not hand you a word. It hands you this. A height for every possible next word. Mat is tall, rug a little shorter, floor shorter still, and a tiny stub for banana. These are example numbers, but the shape is real. This is the model's opinion. And that is the thing nobody tells you. A trained model never actually writes anything. It votes. For every spot, it gives you a full distribution over the whole vocabulary, around 50,000 words, and then it stops. Its job is done. It has opinions, but it has not made a choice. Somebody still has to reach in and pick one word. And here is the surprise. That somebody is not the neural network. The picking happens outside the brain entirely, in a separate little rule we get to choose. That rule has a name. It is called sampling. So, how should we pick? The obvious answer, the one your gut screams, is just take the tallest bar. Every step, grab the single most likely word and move on. This is called greedy decoding, and it feels unbeatable. Always the most likely word, what could go wrong? It is deterministic too. Same prompt, same output, every single time. Clean, predictable. Let's run it and watch the most reasonable sounding idea in this whole episode fall flat on its face. It starts fine. The cat sat on the mat. Period. Lovely. Now keep going. The cat sat on the mat. The cat sat on the mat. The cat sat on the mat. It is stuck. Greedy decoding sends real, fully trained models into loops like this, over and over, the same line stamping down the screen. And this is not a bug in some sloppy model. It is what always picking the safest word does. Here is the deep reason, and it is genuinely beautiful. The most likely next word, chosen again and again forever, is not the most likely sentence. Each tiny safe choice nudges the model toward a comfortable rut, and once it is in the rut, the safest next word is just to repeat the rut. In the famous paper that first measured this, greedy decoding repeated itself almost 74% of the time. Human writing? Under 1/3 of 1%. The obvious decoder is the broken one. So if always taking the favor is a trap, let's stop being so sure of ourselves. Oh, new idea. Instead of always grabbing the tallest bar, roll a die. But not a fair die. A weighted one, shaped exactly like the bars. If mat is 60% of the height, then mat wins about 60% of the time. Rug, 1/4 of the time. Banana, almost never, but not never. Watch the pointer spin and land. This is random sampling, and just like that, the loop is gone. Run it again, you get something new. But now we have the opposite problem. Remember, this die has 50,000 sides. Almost all of them are tiny, but tiny is not 0. So once in a while, the roll lands deep in that junk tail on some word that barely makes sense and it gets glued into your sentence. Sample purely from the raw distribution and the text drifts into nonsense, wandering off, almost unrelated to what you asked. We have 2 failures now. Greedy is a robot stuck in a loop. Pure random is a rambler talking gibberish. The good writing lives on a knife edge between them. We need a way to control the die. This is the hero of the episode. The one dial. And it does something almost magical. With a single number, you can reshape this entire distribution, all 50,000 bars at once, flighting the model from cautious robot to wild poet. That number is called temperature. Here is the move. Before we run the final softmax that turns the model's raw scores into bar heights, we take every score and divide it by temperature. One division. That is the whole trick. There it is on screen. The probabilities equal the softmax of the scores divided by t. D is the temperature. You have seen softmax all season. The only new thing is that little divide by t tucked inside. And I have to be honest with you, this is the one spot where everyone's intuition fights the math, because the effect feels backwards. Turning the dial down makes the model more confident. Turning it up makes it wilder. Give me 60 seconds and that will stop feeling backwards and start feeling obvious. Here is the key. Softmax does not care about the raw size of the scores. It cares about the gaps between them. The distance between the leader and the rest is what decides how tall the winning bar gets. And dividing every score by temperature does exactly one thing. It scales those gaps. Small temperature, the gaps get magnified. Big temperature, the gaps get squashed. Watch what that does to the bars. Slide the dial down toward a half. Dividing by a number less than 1 stretches every gap wider. The leader's lead becomes enormous. After softmax, Matt towers up to over 80%, and the rest get crushed into stubs. The model has become decisive, confident, focused, and a little boring. Push the dial all the way to 0 and the leader grabs essentially 100%. That is greedy again. Low temperature is just greedy. Approach smoothly. Now leave the dial at 1. Dividing by 1 changes nothing, so the bars snap back to the model's native voice, 60, 25, 10, 5. This is the true distribution training gave us, untouched. Temperature 1 is the model exactly as it was trained, no thumb on the scale. Most chatbots default right around here. Now let's heat it up. Slide the dial up toward 2. Now we are dividing by a number bigger than 1, so every gap shrinks. The leader's lead nearly vanishes. Matt drops from 60 down into the 40s, and the underdogs, Floor and even Banana, climb up and get real odds for the first time. The model starts taking risks, betting on long shots, surprising you. Push the dial toward infinity and every bar flattens to the same height. 50,000 words, all equally likely. That is pure noise. Pure static. So feel the whole sweep at once. Cold, near 0, the model is a deterministic robot, always the favorite. Warm, around 1, it sounds like itself. Hot, near 2, it is a gambler chasing wild ideas. Boiling, toward infinity, it is gibberish. Every chatbot you have ever used lives somewhere in that narrow, warm band, and now you understand why it is called temperature. Cold is frozen and orderly. Hot is energetic and chaotic. Same model, same beliefs, one dial deciding how boldly it acts on them. Here is the line to carry with you. Temperature does not change what the model believes. It changes how decisively it acts on those beliefs. Turn it down, it always plays the favorite. Turn it up, it bets on long shots. It is a confidence dial, and it is the single knob behind a chatbot's personality. And there is a gorgeous callback hiding here. Last episode, training was all about lowering surprise, pushing probability onto the true word. Temperature is that exact meter run in reverse. Crank it up, and you are telling the model, go ahead, be more surprising on purpose. Now, a quick reality check on the numbers. In the OpenAI interface, temperature defaults to 1 and runs from 0 up to 2, the exact range we just swept. The rule of thumb is simple. Want correct, focused, repeatable answers for code or math or facts? Turn it down toward 2/10. Want a brainstorm, a poem, 10 weird names for a band? Turn it up past 1. The careful accountant and the unhinged poet are the same model. You just decide which one shows up. But there is an honest catch. The very same dial that makes the model creative also makes it more willing to make things up. Crank the temperature for a brainstorm and you get delightful surprises. Crank it for a medical question or a legal answer, and you are literally turning up the model's willingness to bet on long shots, which means confident nonsense. Creativity and chaos are the same move. You are just tuning the dose. This dial decides whether your model is a careful expert or a confident liar. So temperature reshapes the die beautifully. But even tuned, that 50,000-sided die still has a long tail of junk, and a hot roll can still land in it. So we add a second tool that does not reshape the bars, it trims them. The simplest version is called Top K. Pick a number, say 40. Keep only the 40 tallest bars, throw the rest away completely, then renormalize what is left so it adds back up to 1. Sample only from the survivors. The junk tail is gone. GPT-2's release samples used exactly this, top 40. But top K has a rigid flaw. The number is fixed. Sometimes the model is dead certain. One word should clearly win, and keeping 40 options just invites mistakes. Other times, it is genuinely torn between dozens of good words, and a hard cut at 40 throws away perfectly fine choices. A fixed count cannot tell the difference between confident and uncertain. So, here is the smarter idea, the one production systems actually love. Instead of keeping a fixed number, keep a fixed amount of confidence. It is called nucleus sampling, or top P. Sort the bars tallest first. Now add them up, left to right, and watch the running total climb from 45% to 70 to 82 to 90 and stop. The instant the total crosses 90%, draw a line. Everything to the left, that little cluster covering 90% of the model's confidence, you keep. Everything to the right, you drop. Renormalize and sample from that nucleus. You are keeping just enough words to cover how sure the model is. And here is the part that makes it sing. The pool breathes. When the model is confident, one word already covers 90%, so the nucleus shrinks to a single option, basically greedy, no junk possible. When the model is unsure, it takes a dozen words to reach 90%, so the pool opens wide and the model gets to be creative. Top P sizes itself to the moment. The recommended sweet spot in the original paper is around 95%, and in practice you use temperature and top P together. Temperature shapes the die, top P trims the tail. So now we know how to pick one word, beautifully. But a sentence is not one word, and this is the part worth slowing down for. A sampler gives you exactly one token, just one. To get a whole sentence, you have to do something that sounds almost too simple. You take the word you just picked, glue it onto the end of the input, and run the entire model again from scratch. That is it. That is the loop that turns a probability machine into a writer. Watch it spin. The cat sat on the run the model. Out comes a distribution, sample, mat. Now append. The input becomes, the cat sat on the mat, and we run the whole tower again. All 96 blocks, every bit of attention, fresh distribution, sample, a period. Append again. Run again. Distribution, sample, append. Distribution, sample, append. Round and round, one word per lap. The sentence growing a token at a time until the model rolls a special end token and stops. This is autoregression. And now put it next to a loop you already know. Way back at the start of this series, learning was its own loop. Predict, blame, nudge. Predict a word, measure the surprise, and gently adjust the weights. That loop tunes the brain. This new loop, the generation loop, is its mirror twin. Predict, pick, append. Same circular shape, but here the weights are frozen. Training changes the model. Generation walks the finished model forward. Two loops, one machine. One builds it, one runs it. And this loop quietly explains two things you have always wondered about. First, why does a chatbot's answer stream out word by word instead of appearing all at once? Because that is literally how it is made. One word per lap of the loop. You are watching the loop turn in real time. And second, why do longer answers cost more and take longer? Because the model runs from scratch for every single word it says. A 500-word reply is 500 full trips up the entire tower. There is no writing ahead. It rereads everything and redecides every token. And those tokens, the things popping out of the loop, are exactly the tokens from earlier in the series, run in reverse. The model picks token pieces, mat, a period, a space, and they snap together into readable words and punctuation on the way out. Picking and stitching, lap after lap. That detokenizing on the way out is the last little gear, and now the whole machine is turning in front of you. So let's close the three loops I opened. The dial is temperature, one number that divides the scores and reshapes the whole distribution, sliding the model from frozen robot to boiling noise with the warm, useful zone in between. The trap is greedy decoding, the obvious choice that loops forever, which is why a model has to take real risks to sound alive. And the loop is autoregression, sample one word, append it, run the whole thing again until the sentence is done. Vote, pick, append, repeat. That is how numbers become language. Step back and look at what you have. Tokens flow in, embeddings turn them into places, attention lets them talk. Blocks let them think, stacked up the highway. Training shapes the distribution. And now sampling and the loop turn that distribution into flowing, living text. The entire path, end to end. Nothing about how a language model writes is a mystery to you anymore. You have watched every gear. Which leaves exactly one question. This little machine, happily finishing the sentence you started, one word at a time, is the same shape as the thing everyone is talking about. So take this exact loop, this exact brick, this exact dial, and scale it up. More layers, more data, more compute. The babble sharpens into Shakespeare, then into code, then into conversation. And you start to wonder something almost unbelievable. Have we, across these episodes, quietly built a tiny GPT? Next time, we find out.